students, today we will do the formal derivation of Schrodinger wave equation. So today we are going to do Schrodinger wave equation. This comes under two headings. One is time independent form and another is time dependent form. Where in the last expression of this equation, the factor of time comes explicitly, we call it a Schrodinger time dependent wave equation. And if in this equation, the factor of time doesn't appear, we call it time independent Schrodinger equation. The preliminaries with regard to this topic have already been discussed, I believe, in the previous one or two short videos. Today we will directly proceed towards its derivation. I hope all of you are aware of the three-dimensional general wave equation given by Maxwell, and that is del square psi is equal to 1 by u square dou square psi by dou t square. This is the general equation for wave motion, which I believe that you have done in your previous semesters. Even if you have not, it's not a big deal to do it. We can do it at any later part of time. Psi is the wave function, and this equation relates the space variation of wave function with the time variation, and u is the wave velocity or phase velocity. Or phase velocity. So let's choose a wave function now. Psi of RT, that means we are defining psi at a point in space and time, that's equal to psi naught of R e to the power minus iota omega t. Here we know that del square is the Laplacian operator, and we can choose to write it as del square is equal to dou square by dou x square plus dou square by dou y square plus dou square by dou z square. If you are okay with that, then we proceed ahead. Now, let us differentiate psi with respect to time twice. Dou psi by dou t is equal to psi naught of R e to the power minus iota omega t, and then this factor of iota omega will also come out. Next, dou square psi by dou t square is equal to this psi naught R is again there, this e to the power minus iota omega t is there, and this factor again appears, so it is minus iota omega square. So it is, iota square is of course minus 1, and with this minus it becomes plus, so it is omega square psi naught of R e to the power minus iota omega t. Right? So if we substitute it back in this equation, we get del square psi is equal to, for this we can write omega square by u square psi. For this we can choose to write psi. And of course this minus sign will remain. Now let us choose to work with this omega. This omega is of course 2 pi nu, and for this nu we can write 2 pi u by lambda. I hope all of you are aware that u is equal to, that is nu is equal to u lambda, the simple relation between wave velocity, its frequency, and wavelength. So omega by u is equal to how much? 2 pi by lambda. This implies that omega square by u square is equal to 4 pi square by lambda square. So we can choose to put this value in this equation, and that is del square psi plus, for this we can choose to write 4 pi square by lambda square, psi is equal to 0. Now, since we are basically associated with matter waves in case of Schrodinger wave equation, our aim is to have an understanding of matter waves, the waves that are associated with every material particle. So, it's very logical to introduce the concept of de Broglie waves. For that, we know the elementary concept that lambda is equal to h by p, which is also equal to h by mv. So for this lambda, we can substitute h square by m square p square. So let's do that. That is del square psi plus 4 pi square. For this lambda square, I can choose to write h square, m square, v square, psi equal to 0. Now, if E is the total energy of the system, of the particle, and V is its potential energy, then the kinetic energy, which is generally denoted by T, is obviously given by E minus V. So this kinetic energy, which we know is 1/2 of mv square, that is equal to E minus V. So you can choose to write mv square is equal to twice E minus V, or m square V square is equal to 2m E minus V. So let's substitute. We get this factor here, m square V square. That's why we are interested in this kind of exploitation. So del square psi plus 4 pi square by h square. For this I can write 2m E minus V, psi is equal to 0. Now, since you are beginners in quantum mechanics, there are some new terms, notations and symbols that I believe you should try to live with. And one such term is h cross. H cross is simply h by 2 pi. So that way you will be able to identify this term with 1 by h cross square. So what do we write finally? Del square psi plus 2m by h cross square E minus V, psi is equal to 0. This particular equation is called Schrodinger time independent wave equation, because the factor of time does not appear explicitly in this equation. So this is Schrodinger time independent equation.